welcome back to Electricity Hoopers to Be. In this session we're going to be thinking a little bit about solar power.
Now, when you first think about solar power, you might be thinking of one of these, pocket calculator, which has a little panel at the top. Now, this is an example of solar power. It's a very small, what we call a photovoltaic cell. And all that means is it takes the light and converts it into electricity. Now, in this case, with the little calculator, it only needs about 1.5 volts, so the same as a AA battery, and that's enough to make the calculator run. But this particular one, it can be supported by a battery, but I've taken the battery out to show you. As soon as there's no light, it can't cope anymore and it gives up. Now, at this scale, that's absolutely fine, it'll run a calculator, but if we want to use it for something more substantial, we're going to need a much bigger panel. Now, this is a much bigger panel. Just give you a sense of scale. It's not all that big, in fact, it's about the size of an A3 piece of paper. But this will do much more than my calculator. If we just have a little zoom in, as you can see, there are 36 of these small rectangles. Now these are the photovoltaic cells, just like the ones in the calculator. And what they do is they soak in the sunlight and convert it into electricity. So what we've got here, if we look very, very carefully, a series of incredibly thin wires, a little bit like in the motors I showed you in another episode, and they're running up and down, up and down, up and up and down. They take in that electricity and send it all through to the back. So let's have a little look what's on the other side. So all of those panels feed into this black box. We have a little look inside. It's not wired up, so it's perfectly safe, but if you ever get the chance to touch a solar panel, please do not touch one that's wired up. Okay, so we've got the two main wires here. This one going straight through to the black, which is the negative. This one connected to a small black device here. Now that is another example of a diode. We talked about diodes in a few episodes. We've got light emitting diodes, LEDs, buzzers type of diodes. All a diode is, remember, is something that doesn't allow electricity to flow both ways. So in this case, it only allows electricity to go out from the solar panel. It doesn't allow electricity to go back in. Now that's very important, because if you allow electricity to go into a solar panel, it will destroy all those little wires on the other side and it won't work. Now on the back there's also a little explanation of the specifications of this panel. I'll just go into a little bit of detail with this, not much. This is a 25 watt panel, 25W. Now the watts is the amount of power that the panel has. So 25 watts, not very much at all. To give you an idea, a kettle is usually around about 1,500 watts. Now also, we've got the amps, 1.4 amps. Now amps is a measure of the current in a circuit, so it's sort of like how powerful the circuit is. So you can have a 12 volt circuit, you can have a 20 volt circuit. What matters is how many amps is flowing through it. So for example, if I take the kettle again, the average amps going through the wire of a kettle is about 13 amps. So this one, 1.4 amps, is quite low because it's only a small panel. Now, to make my solar panel of any use, I'm actually going to have to wire it up to something. So after it comes from the diode, it goes through this long cable and out to the two wires here, the positive and the negative. Remember, red positive, black negative. Now, I can't just wire these straight up to anything, because the voltage in the amps coming out isn't very consistent. It's jumping all over the place. At the moment there's none at all because it's face down on the table, but if it was facing sunlight, then it would be giving sometimes 12 volts, sometimes 13, sometimes ending up to 17.9 volts. The reason it's above 12 is because you always lose some electricity as it travels through the wires, so it has to be more than 12 volts to charge up the 12 volt battery, which is what we're going to need in a moment. First, we need a little bit of equipment that looks a bit like this. You can get all sorts of these. The ones in houses are much, much bigger and do fancier things, but this is a simple solar charge controller. And all this does is when the voltage comes in through the solar panel, it keeps hold of it and sends it out in a slow, steady stream into the battery. Let's have a little look at that. Okay, so the battery, we've got a yellow wire coming from the negative connection and a red wire coming from the positive connection. Sorry, a blue wire coming from the positive connection, and that's going into the solar controller. Now, at the moment that's showing that the battery has got 12.7 volts, which is quite healthy, and it's almost completely full. There's also a little light bulb there that says it's quite safe to run things off this battery. But now we need to wire in the controller. Sorry, not the controller, the solar panel, which is why we're going to put these wires in here. So the wires are in, positive and negative, red and black. But nothing's happening. Oh no, that's because the panel is face down on the table. Let's actually offer it up some sunlight. And you can now see there is a little symbol, it's meant to be a solar panel, which shows that it is feeding electricity into the battery. Yeah, because I'm pointing it out the window. Now, it's not going to give it very much electricity like this because I am inside and because the windows have got what we call ultraviolet protection. That means they're not letting in as much sunlight as they should. For best results, they should be outside, but this is just a little demonstration. So that's all well and good. I've got my solar panel charging up my little battery, and I've got quite a good voltage in the battery. But you might be thinking, well, what's the point of that? The battery's not going to do anything. Well, we can connect it up to something to make it a bit more useful. This is a power inverter. You might notice it says DC 12 volts to AC 220 volts. There's two types of electricity. You've got DC, direct current, and you've got AC, alternating current. AC is what the things in your house run from. So if it's got a plug, it's AC. Except your AC probably turns a lot of things back into DC. But yeah, DC, direct current, that's just your standard circuits. All the ones I've been using so far have been DC. But this clever little device turns the electricity from DC into AC so that I can plug things into it. Let's give that a go. So the inverter is wired up to this one, and I have temporarily used a green wire to wire it up. Now that wire is actually a little bit small for the purpose. You want good thick wires for this, but it's just a quick demonstration. The reason we use thicker wires for this is because there's a lot of amps traveling through this, and if you want this to run for a long time, you'd need a good thick wire so it doesn't get too hot. But this is just a brief demonstration. Now, you might have noticed it's got a bit dark in here. That's because this entire shed is in fact solar powered, and I borrowed this to show you, and I want my lights back. So we've wired it up, we'll switch it on. That beep was just saying it's ready and it's working, so we have a green light, so it's getting enough electricity. Yep. You can see straight away that voltage has gone down to 12.5 volts because it's using that 0.2 just to run the inverter itself, so you use a bit of electricity just through that. But let's plug it in. So again, do not play with AC electricity. That's 220 volts, 13 amps. That is enough to kill you, so you have to be very, very careful. And success. There we are. So my lights in the shed are now running entirely off solar power. So this inverter will run anything up to 2000 watts, as you can see. So it can't quite manage kettles because they require a lot of amps, but it can run the Hoover, it can run my lights, it can run absolutely everything inside the shed, tools, so it's quite handy. With a little battery like this, it won't last terribly long, only a few hours, and with a little solar panel like this, it'll take about 4 days to charge it up, which is why you often see much bigger panels. Like this one. And this one. Well, that's about all we've got time for in the shed today, so I will see you next time.